Hi everyone, and welcome to this presentation. I'm going to be talking about modernizing rendering at Supercell. First of all, I'm going to do a quick overview of kind of the history of rendering at the company and how we got here, to give you a bit of background into why we actually made the kind of decisions that we made. Then I'm going to be talking about the actual process of rewriting the renderer, and finally talk about the role of our kind of unique culture at the company in all of this, and how it kind of helped to make all of this happen. So most of you probably already know, Supercell was founded in 2010, and we're known for games such as Hay Day, Clash of Clans, Boom Beach, Clash Royale, and Brawl Stars, and also learning from our mistakes. My name is Timo Heinäpurola, and I've been at the company since March 2020, and I'm leading the development of our shared rendering technology. So let's talk a bit about how we actually got here. So our first game was Gunshine.net. It ran on Flash, and it was a Facebook game basically, and back in the days, that was kind of the way you could reach a really broad player base. So that is basically what we used on there. The clicker is a bit slow. Oh, that just isn't so. So yeah. Basically, Gunshine wasn't really a success. So we ended up pivoting to we ended up killing the game, and in the process, we thought that mobile was coming, so it was going to be really big. So that's probably the platform that we want to be in, and we pivoted to iOS and Android, and specifically targeting tablets. We did have a history of working in Flash, so it was kind of natural for us to actually continue authoring our content in Flash, but we needed something to actually run this content on these devices. So, yes, that screen isn't working properly, so that's why we have these hiccups. So basically, what we did is that we built this kind of pipeline for converting Flash into this in-house format. And then we had this system called Stage, which would be used for rendering this content in-game. So because we couldn't use Flash to actually render it, we would use our in-house system for this. And Stage is part of Titan, but Titan is a lot more than just rendering. It also contains a lot of common platform technologies such as networking and push notifications and things like that. So it is kind of our engine, or it is more and more becoming our engine, which previously was more like piece of shared code, but now it's becoming this kind of more and more really kind of engine. And it's maintained by the tools and technology team that I'm also part of. So, as you probably know, most of our early games have really been kind of this pre-rendered or fake 3D-ish kind of thing. You have Hay Day, for instance, you have your farm there. All of that is 2D, but it looks a bit like 3D. Boom Beach was the first game that actually incorporated 3D elements. So, well, we're not talking about Gunshine here, which is a separate case, but of the current games. And it has some 3D elements, such as like some units that are 3D and the background is 3D, but it's still relatively limited. And with Brawl Stars, we kind of realized that we can actually provide a lot more to the players with 3D. So we realized that we should actually double down on this and start adding more 3D features, because that kind of brings a lot of it brings a lot to the player. So nowadays, like most of our games, all the games apart from Hay Day, actually have 3D elements in them. So if you look at Clash, for instance, you have the hero characters. Those are actually 3D characters nowadays. But then we kind of ran into a problem here, and Apple decided to drop a bomb which was that they deprecated OpenGL ES in iOS 12. Now, this was a problem for us because we heavily relied on OpenGL ES for all of our rendering. So basically everything that we do or did was built on top of OpenGL ES. So we had some helper layers here and there, but it was really kind of tied to the way OpenGL ES works. Yes, so we thought that we shouldn't just start hacking things together and just do something to make sure that we can also work on iOS in the future. We thought that we really kind of can take this opportunity to future-proof our rendering core. Our legacy rendering path was making it really kind of difficult to implement or to increase our 3D elements in the game because it was complicated to kind of merge the 2D rendering that we had with the 3D. And we occasionally had these things where we had states flowing from the 3D rendering parts to the 2D rendering parts. So it wasn't really kind of nicely componentized or compartmentized, which was leading to issues. So we needed a rendering API that would abstract the details of different platform-specific APIs and allow developers to focus on the actual rendering algorithms instead of the detailed implementations on specific platforms. And they shouldn't really care too much about individual OpenGL states, whether they're set to which values. They should be able to just say that, okay, I need these things for this material, and that's how it should go. Enter THOR. That's short for Titan Hardware-Oriented Render. THOR is basically this internal API. It abstracts currently Metal OpenGL, OpenGL ES 1 and 2 as well, 2 and 3 as well, and Vulkan. So when I joined the company, we had like a skeleton implementation of THOR already in place. So there was some architecture, there was like a very simple implementation of the OGL backend, the Metal backend. But it was lacking a lot of like core concepts, such as even uniform buffers. So there was a lot of work to be done. So during the spring of 2020, I worked on THOR pretty much in isolation. So I had this kind of test project that where I had these very kind of simple tests for creating textures and using them for rendering, just like rendering triangle batches and things like that. So kind of very simple, but there wasn't really a game that would actually use any of that. So I was, and pretty much like not a lot of people in the company actually knew about this at this time. So right before summer holidays, then I finally got Heyday to actually run on THOR. So it had enough features so that we could render most of the game content using the system, but it wasn't anywhere close to kind of production ready at that time. We had decided to target Heyday first because it had the most kind of limited set of features that we actually needed for the game, and we wanted to get THOR out into the wild so that we could actually get some, some experiences from having a live game on that and how well it actually performs, if we're going to run into some issues like performance issues or crashes and things like that, and then to start ironing out those kinks, and then building on top of that. So after getting back from summer holidays, I focused on improving THOR for the needs of Heyday, basically optimizing things, adding small features that we're still missing, like custom shaders for stage rendering and things like that. And it was really easy to work with the team. Basically, we have this kind of really open culture, and really kind of every team is approachable, and you can go and talk to anyone basically if you need to get something done. So when I needed to know something about like our build environments, I needed to implement like shader builds. So I needed to talk with the build engineers. Then I needed to ask questions about, okay, where is this, let's say like your farm customization view actually rendered, so that I could figure out why it's upside down and things like that. It's still a problem, the upside downness. And yeah, Heyday went live with Thor in end of 2020, so that it was the first game to actually use Thor, and we were able to gather a lot of experience from that. Luckily, the release actually went really well, and we didn't have a lot of issues. We had some, but it was surprisingly smooth. And after that, I've basically been kind of jumping from game to game, developing the core of Thor at the same time, but also porting those games onto Thor. The second game to be ported was Clash of Clans. And Clash was actually the first game that had 3D that was ported. So I actually had to do a lot of stuff to make that happen. Things like multiple buffer bindings and things like that, that are related to kind of 3D and 3D materials. So this was kind of one of the biggest jumps from what we had originally. The next one was Clash Royale, and this was actually started while I was working on Clash of Clans, but due to the release schedule of the game, it was released actually quite a lot further down or later, but it was relatively smooth sailing because the 3D is very limited, just like individual boxes in your that you can buy and open. So that was done kind of already in Clash of Clans. Then the third game was Brawl Stars, and this was perhaps the most complicated one because of the heavy use of 3D, and I had to do a lot of bug fixing basically, and like making sure that it works on all the different major Android device sets, and the port itself wasn't too hard. It was done relatively fast, but then we had to wait for the QA a bit because they were stuck in a release before this one. And basically, when we started testing it, then we started noticing all these kind of small issues that came from the more complicated use of Thor in Brawl Stars. So it took a bit longer to actually ship that one. And then finally, Boom Beach is actually the last game that is still, the live version is still using Thor, but there is an update coming in the near future. So the porting work is kind of already done, but the live version still uses the old render. But yes, that was just the beginning. So basically, after porting all the games, the work on Thor has continued nonstop. So of course, our new games that I can't talk about use a lot of features, and we want to push Thor. We want to, create new, more vivid environments and all that. So we're of course constantly developing Thor forward. The first major learning of this whole process, I think, is that QA is really important, especially in our case where we have these multiple billion-dollar games that we need to be porting. We're basically rewriting the core of our rendering. So we have to be really careful. And QA was really amazing in here, and they allowed me to sleep my nights in relative comfort. And also, our company culture has been really crucial in the adoption of Thor and the development of that. I'm going to be talking about that. So we basically have this kind of culture where it's all about empowering people to do their best work. So we don't have a lot of red tape. So whenever there's something that you need to get done, you can basically just go ahead and do it. Of course, it's up to you to make sure that you're doing the required research, that you're actually doing a decision based on facts, and you can stand behind your decision, but there aren't a lot of things that are kind of stopping you from doing that. And this basically allowed me to work directly with the game teams and not have a lot of bureaucracy to deal with. Basically, whenever there's something that I needed to get done, I could just talk to the team and figure out the best way to do it, and then just do it. We also see failure as an opportunity to learn and improve. And this can be really, this is really so. It's not just about marketing speech. And this was a really important learning for me as well. And there's actually one example that I'm going to be presenting here in the next slide, I think. Yes. But of course, it's not all roses. There are problems. Like, people have made decisions based on lacking facts, but it's really kind of up to them to, improve the situation. And but yes, those are also kind of failures that we need to learn from. Then an example of the kind of failure culture. The failure is okay. And this is actually a feature that went out in Town Hall 15, Clash of Clans just recently, pre-built shaders. THOR has, if you could say historically, even though it's not a long history yet, you could say that we've been building our shaders so that we use GLSL as our source code, and then we compile that into SPIR-V, which is like an intermediate shader language format, and then we convert that into Metal shading language and back to GLSL for OpenGL. And this happens at runtime. When you start the game, it basically does this process and gets the final shaders that it can use on the device. Now, this isn't a very fast operation. So what I started initially doing was that I implemented this kind of caching mechanism where you would only do that when you first start the game and the shaders had changed, and then you would cache that and reuse it for later. So you could skip most of the time, this whole process. But then, I had this working and I was ready to merge it into the trunk and, all that. And then I had this discussion with a colleague of mine about how SPIR-V cross handles specialization constants, which was actually one of the reasons why we did this at runtime anyways. And then going through that, I realized that actually we don't have an issue with them. So we can pre-compile everything and then just use that at runtime because of the way it actually defines the specialization constants. So I ended up ditching the implementation, and it worked, but it wasn't as good as it could have been. So I ditched that and went back to the drawing board and implemented this new feature, which ends up being a lot better. So that's an example of don't be caught up in the sunk cost fallacy. Really analyze, is this smart that you're doing here? And could you do it better? So looking into the future, now that THOR is in active use within the company, we can finally focus on building on top of it. So THOR makes it a lot easier for us to share implementations between different projects. So now, because we have a common baseline, we have this common API that we can build things on top of, it's a lot easier to just move those implementations around. If not just copy-paste or implement a shared version in Titan, then at least to use that as a template and quite easily implement it in another project. And currently, we're also building a kind of a higher level rendering layer to leverage the power of THOR, because THOR now has a bit more of a kind of strict way of defining how you render things, how you define your draw calls, and how you define your resources. Previously, we couldn't do that because of the free-form nature of OpenGL. And now we can kind of more easily, we can utilize kind of these limitations, if you will, to build a new system that is just a lot clearer and doesn't need a lot of kind of hacking for different kind of specific situations. So yeah, that's pretty much it. So time for conclusions. So one really important thing is that we always build our technology for a need. So we don't go and just figure out, okay, this is something fun that I want to work on, and then we just do it because it's fun. That's not how we do things. We might occasionally run into things like, okay, this is actually cool. Could we really use this? But we think about how can we use this, or is this important for us? Does this really matter? And then we go about implementing it if it can really bring value to the game and to the players in the end. So THOR was like a necessary step, first of all, a necessary step for us to future-proof our rendering. We needed that to run on iOS, but we also saw this as an opportunity to make things better and to kind of provide more value to the players in the future as well. I also went through the quick history of kind of the challenges of porting THOR and how the overall process went. This is skimming kind of, over the topic. So if you want to ask more questions about this afterwards here or after the presentation, I'll be happy to answer. And then finally, I also explained how our culture enabled us to do this. So in a culture where you have a lot more rigid decision making and you have to go through a lot of hoops to get approval for things, it can be a lot more complicated and you can need a lot more people to do this. But basically, we kind of managed to do the whole thing with like one person over a couple of years in a pretty safe manner. Of course, like one implementing person, and the whole company was behind that and supported and all that. But because of our culture, like how it enables us to do things without all this red tape, it was just so much faster to get things done, to actually get to decisions. And a final mention, yes, this shows it. So I'm also on Twitter, so if you don't happen to be able to ask a question here, just go on there, and I'm open for questions. I also occasionally tweet about engineering stuff at Supercell, also a lot of like other stuff as well, but you can skim over that if you're not interested. But yeah, open for questions. Thank you very much.
Yes. Any questions from the audience first?
Yes, I have a question, and it might be a naive one, but I was just wondering when Apple basically told, like they said that OpenGLES was getting deprecated. Did that basically, like the outcome of that was that new Apple devices, they would not support your games, right?
At some point in the future, which is not disclosed. Yeah. So there is no kind of, because it's deprecated, it might be killed at some point. Theoretically, it might hang around for years, but there's no kind of security that it'll actually hang around.
And so it would be like, it could potentially be removed from the App Store itself.
Yes, it could be that in one iOS release at some point in the future, you will not be able to play any games that are using OpenGLES.
I see. Thank you.
Yes.
More questions from the audience? Can I ask you then something from me?
Of course.
My first job was a developer, so I'm very interested about, would you implement this, I like that question, would you start that process? What's the motivation? Because of that, the feature is not going to be supported, or would you still rather do it anyway?
I think that was really kind of one of the best selling points for it, because how do you sell this thing? Well, if you want to release on iOS in the future, then you'll probably want to use this. But I still think that the legacy systems that we had were really kind of hard to use in the future. Like the kinds of needs that were popping up in our new games, in our current games, kind of showed that this is going to be really challenging to do all of this without kind of revamping our systems. So definitely we would have run into this issue and we would likely have made a similar choice. But probably we might have started making that decision either this year or last year or something like that. But we wouldn't have been pushed into this in a similar way.
Thank you. I'll read the questions from online. Vaisa, do we have any questions online? Or from the audience? We still have a few minutes.
I would like to know, you say that you create THOR because they need it, because you need for the company. they develop the games. But also you say, now I am nervous. Also you say that maybe at the moment it's not covering everything that you need. For example, the upside down. So are you thinking to force THOR to cover all your needs, or maybe you thinking, are you open to create something new, like a complement? I don't know, Iron Man, Captain America.
Yeah.
That sounds like complement with THOR.
THOR is kind of the bottom layer for everything, all the rendering that we do. So that is our way of communicating with the platform-specific API. So that is kind of a must that you have to use. But then there are like layers that we're building on top of that, which you can pick and choose. So you can use like, let's say like the new system we're building has like meshes, materials, and stuff like that. Then you might want to use like the meshes and materials, but probably not the scene definitions, or you would want to use those parts, but maybe not kind of the rendering, threading organization stuff that we also have. So you can kind of pick and choose on there. And we do think that THOR is kind of this bottom layer that is shared, and then on top of that, we have these different components that you can build on top of. And actually, the upside issue is kind of solved. The problem is just that the actual problem is that in Metal, everything is kind of drawn upside down into the frame buffer. In Vulkan, everything is drawn upside down, but the normalized device coordinates are also upside down. So it goes further with the upside down. So I think it's somewhere in the Stranger Things realm with that. Yeah.
Thank you, Timo. Thank you very much. Thank you for the questions. We're going to move on with the program. Timo, do you have a moment to stay if somebody wants to come and have a chat?
Yeah, I'm not in a hurry.